we are going to expand on this sequence thing from yesterday, and we're going to start adding things together. So I want to start with something called partial sums. So let's take a look at a sequence. Now let's have this sequence be 1, 3, 5, 7, ... And this would be a sub n equals 2n minus 1. So we have this sequence expanded, and we are going to find the first 6 partial sums. So I'm going to show you what that looks like. Partial sums are adding up a finite number of terms in a sequence. So S sub 1 represents the very first partial sum, which is just the first term in the sequence. S sub 2 means take the first 2 terms in the sequence and add them together. So S sub 2 is A sub 1 plus A sub 2, and it would be 4. S sub 3 would be 1 plus 3 plus 5, and that's going to give us 9. S sub 4 is 1 plus 3 plus 5 plus 7, and that's going to give us 16. S sub 5 is the sum of the first 5 terms, and that works out to be 25, and S sub 6 gives me 36. So I could list out the terms of my first 6 partial sums like this: 1, 4, 9, 16, 25, and 36. And I could look at this and I could actually come up with a formula for my nth partial sum. So what we're going to do is look at patterns here. So what is this formula? Well, you can see that all of those numbers there are perfect squares, and that's how you get the perfect squares. You sum up all of the odd numbers until if you sum up the first 3 odd numbers, it's 3 squared. If you sum up the first 4, it's 4 squared. So this is a formula for S sub n, and that would be n squared. Let's take a look at another one, and instead of the first 6 partial sums, let's just go straight to the S sub n. So what if we had a sequence 2 over 3 to the n, which would be equal to, like 2 thirds, and then I've got 2 ninths, and then I've got 2 over 27, and 2 over 81. All of the denominators are powers of 3. And let's just say we wanted to come up with the nth partial sum. Well, we need to come up with a pattern, so let's find some partial sums here. S sub 1 is just 2 thirds. S sub 2 is 2 thirds plus 2 ninths. And that works out to be, if you do common denominators, 8 ninths. S sub 3 is the sum of the first 3 terms. It's 2 thirds plus 2 ninths plus 2 over 27. And that works out to be 26 over 27. S sub 4 works out to be 80 over 81. Let's take a look at this list. Our partial sums look like this: 2 thirds, 8 ninths, 26 over 27, and then 80 over 81. And what we want to do is see if we can find a pattern. In the denominator, you can see that we've got nothing but powers of 3. So that's pretty easy. It's just 3 to the n. But what do you see in the numerator? In the numerator, all of those numbers, the 2, the 8, the 26, and 80, happen to be exactly 1 less than the denominator. They're exactly 1 less than that. So my numerator would be 3 to the n minus 1. So there's another example of finding the nth partial sum. Let's take a look now at something called sigma notation. Sigma notation is this funny looking bold E. This is called a sigma. And you are going to get a letter down here that's usually an I, J, or a K. We'll start with a K. And this is called your index of summation. That simply tells you what to look for in your formula over here. Then you will get a lower bound, and that's typically 1, but it can be 0 or other things. You'll get a lower boundary. That tells you where to start. And then you will also get an upper bound. That tells you where to stop. What this means is you are going to add up a whole bunch of things. And let's add up all of the k cubes. This means add up all of the first 4 cubes. This would mean plug 1 in for k, 1 cubed, and then write a plus sign. And then kick your k up by 1 to the next number, which would be 2, and plug it in. And if you plug in 2 for k, you get 2 cubed. And then plug in a 3, and keep plugging numbers in until you get to the upper bound. That's what this summation means. It's a shorthand way of showing to add up a bunch of things. And if we add these all together, we're going to get 100. Now, you can also do this on your calculator, and I want to show you what those keystrokes look like. So you're going to go to, make sure your mode is here in sequence mode like yesterday, and then we are going to go to second stat. You can see the buttons I'm pressing over here. We're going to go over to math, and then we're going to go down until we see sum. And I'm going to hit enter. And then we're going to hit second stat again. We're going to go over to operations, and we're going to go down to sequence. So I'm going to sum a sequence. Then I'm going to tell my calculator what the sequence was. Here it was k cubed. Well, when you press your xt theta n, you're going to get an n here. N cubed, and then comma n with respect to n, and then comma the lower bound, comma upper bound. And it tells you that the sum of those first 4 cubes is 100. Let's take a look at one last example, and that is how to write something in sigma notation. This will be our last example here. Get back to blue because I happen to like that today. We're going to do 1 squared plus 2 squared plus 3 squared plus dot 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 all the way out to 10 squared. And our goal is to write using sigma notation. So I'm going to first of all figure out how many terms I have and what they start with. I'm starting with 1, and I go all the way out to 10, and I have 10 things here. So that gives me a hint here what to use. I'm going to use I this time. I equals 1 to 10 because I have 10 terms. Then you just have to simply ask yourself what's happening to those terms. We are squaring them, and that's how you write it using sigma notation. So this is what you guys will practice tomorrow, and I will see you then.